Hello students. So as a teacher we have a mantra that states that I would be an optimist that is proven wrong than a pessimist that is proven right. So with that being said, I hope that you are practicing your maths daily, and I'm going to today end the chapter sets, and this is the last part of the chapter sets. Alright. So in this part we'll be doing about the relation of number of elements in the set. Okay. And by number of elements in the set, exactly, we are talking about the cardinal numbers. Okay. Now you must remember what cardinal number is. Okay. That being said, so we have got certain relations. We are going to note it, and then I'm going to explain it how it is functioning in the way that it is here. Okay. So first here it says that number of elements of A union B is equal to number of elements of A plus number of elements of B minus number of elements of A intersection B. Okay. And then likewise, number of A union B equals to number of A plus number of B. If A intersection B is a null set, you must be knowing A intersection B is a null set, then the sets A and B will be known as disjoint sets. Simple. Likewise, we'll be talking about A symmetric difference between B. So what happens when symmetric difference are operated? What happens is all the elements that are A and A exclusively only, similarly all the elements of B and B exclusive only should be only counted as well. Okay. So in this case, we'll be seeing that formula is number of A plus number of B minus 2 times number of A intersection B. Alright. And last one formula, this number of A minus B is all the elements including the elements that are intersecting with A and B and the elements of B. When removed from A, what is left is all the elements that are for exclusively A only. Okay. So that would be number of A minus number of A intersection B. Okay. Now this being said, these are the formulas that we are going to discuss, and this is generally for just 2 sets. After completing the 2 sets, we'll be talking about 3 sets as well today. Okay. Yep. So let's go with the explanation how this formulas and relations came about. So generally speaking, the relations that are over here can be explained through Venn diagram. Okay. So let's talk about 2 sets, sets A and set B. Set A has certain elements, say 1, 2, 3, 4 and 5. Similarly, let's say set B has certain elements, 1, 3, 5, 7 and 8. Alright. Clear? Now using Venn diagram, we can see how the elements go about. First, this is set number A. Set A. Similarly, this is second set, set B. Okay? Clear? So as you remember, this part is the intersection part. Alright? Now for intersection part, you can see clearly that 1 is being repeated. Okay? 3 is also being repeated, and then what is being repeated? Number 5. Okay. So 1, 3 and 5 will be written in this region. Simple. Alright. Now what is left? 2 and 4. 2 and 4 are the exclusive elements of A alone. Alright. Next one, B. What is being written? 1, 3 and 5 has been gone. So 7 and 8 are remaining. 7 and 8. Alright. So from the first relation, you can see that numbers of elements in A union B, for example, in this case, we all remember what a union is. Union is all the elements, the amalgamation of all the elements that are present over here. So number of elements of A union B. How many elements are there? You have to discard all the elements that are being repeated, and it will be counted only once. So 1, 2, 3, 4, 5, 6, 7. So total 7 numbers, 7 digits are present in the A union B. So that would be the number. You have to write down the count. Okay, not the element but the count. Similarly, after writing A union B, number of elements of A. How many elements were there? 1, 2, 3, 4, 5. 5 count. Okay. Similarly, the count of number of elements of B. Again, 1, 2, 3, 4, 5. 5 counts. And number of A intersection B. As you can see clearly, how many numbers have been intersected? 3 intersections. Alright. So, from here it is clear that A union B, when added these two numbers, from here it is clear that number of A union B equals to number of A plus number of B subtracted by number of A intersection B. So, from the values you can see clearly. Alright? Clear? Okay. Now, the question arises, why is being this subtracted? Okay. And it is obvious, you can see. From number of A, this whole circle is being counted. So, what happens is, these 3 digits have been counted already. Now, if you're adding to it number of B as well, okay, then what is happening? This is again counted. Okay, so there is twice addition of these 3 digits count. So to subtract this count, we are subtracting this value. After subtracting this value, then we are going to get this whole region, which is the union operation. Simple. Okay. Now what happens if in a set we have certain set that does not have repeated elements? For example, let's say instead of 1, 3, 5, we have say 3 elements, 6, 7 and 8. Okay. So as you can see over here, there are no common elements. Since there are no common elements, so this Venn diagram would change slightly. Okay. After slight change, it would be something like this: 1, 2, 3, 4 and 5. All the 5 elements being written in set A. Okay. Similarly in set B, 6, 7, 8. 6, 7, 8. So what is happening? The intersection part is null. It is void. Since it is void, I'll be repeating this. And when this is being removed, you need to specify that number of A intersection B is a null set. This is your second rule. Okay, or second relation. Okay, so in this case, what is happening is set A and set B are disjoint. Okay, simple. Now for the third relation. So in this relation, what we are checking out is, we are checking out the count of the elements present in A symmetric difference with B. So what does it imply? Set A and set B. Okay, we are going with the 2 sets. So these are 2 sets. Your set A is, say, elements 1, 2, 3, 4 and 5. Again same thing. And say B is element 4, 5 and 6 and 7. Something like this. Alright. Now as we know, symmetric difference is usually written in A minus B union with B minus A. This is how we represent symmetric difference. Okay, this part we discussed earlier again. Alright, so over here you can see clearly the number of elements in A minus B union B minus A in Venn diagram represents which region? So A minus B union B minus A represents region, this part which is shaded. Okay. So clearly you can see which part has to be subtracted. Okay. So which part is to be removed is this part. Clear? So you can write A symmetric difference with B equals to number of A whole added plus number of B whole added. Okay. Now what is happening? This whole circle is being added plus this whole circle is being added. So what is happening? I have to remove this completely. To remove this completely, I have to subtract how many times? Minus 2 times number of A intersection B. Simple. Okay. Now for the fourth part, we have to find the number of elements in difference of B from A. Okay, so we are subtracting elements of set B from elements of set A. So again, let's take example. Let's say set A is 1, 2, 3 and 4, and then let's say set B is certain elements 3, 4, 5 and 6. All right. Now you remember what is difference of sets. Okay. This operation, difference of set, what is happening? We all remember. Say this is set A, this is set B, and from set A we know the elements are 1, 2, 3 and 4. From set B 3, 4, 5. What is repeating? 3 and 4, where it has to be written between the intersection part. Okay. Now what is left? 1 and 2. Same thing over there. What is left? 5 and 6. Okay. Now that being said, as I said, the difference between two sets is dependent on which set is being written first. Okay. So in other words, A minus B can be stated to be exclusive elements of A only. So this only is a stressed and important line. Okay. So number of elements of A minus B in this case is how much? It is this part. Okay. Only this part, which is 2. Now how do you write it in relation? So to write it in relation, the first element is A, therefore all the elements of A, including the intersection part as well. Okay. So from this I have to subtract the intersection part. A intersection B. After subtracting the intersection part, so from the set A, all I'm going to get is the exclusive part only. Okay. So from here you can see it is 2. Clear? This is a question that is based on the theories that we discussed earlier, the relation between the number of elements. Okay. So as you can see, there are 2 sets of people. Okay. So first set is the person that likes coffee, and the second set is the person that likes tea. Okay. So you can see the number of people liking coffee are 37. So number of people who like coffees are 37. All right. Now this is your given part. All right. Similarly, number of people who like tea, how many? They are 52. And as you can see, it has been said clearly that each person likes at least one of the 2 beverages. That means each person has to be either coffee or tea or both of them. Okay. So that means the union of the coffee people and the tea people is total 70 people. Okay. So number of coffee union tea equals to 70. Simple. So what you need to find is how many like both the beverages. That means you have to find the number of people that have affinity for coffee. What was written first? Coffee and tea as well. Okay, so this is intersection generally. So you can see from the relation it was clear that number of A union B equals to number of A plus number of B minus number of A and intersection B. Okay, so if you transpose intersection to this side and union to that side, what is happening? Sign remains, the relation remains same without any change. All you need to change is union to intersection. Okay, so same thing happens here. So this should be number of coffee plus number of tea minus number of coffee. Intersection has to be found. So I have transposed it already, and this would be union. Simple. So number of people that like coffee and tea would be equal to number of people liking coffee, 37, plus number of people liking tea, how many? 52, and subtracted by number of coffee and tea, which is 70 people. So this gives me 7 plus 2, 9, 89 minus 70. This should be 19 people. Okay. So from this relation, we can find out the number of people that like coffee and tea both. So which is 19 people. Okay. So I would like to remind you all one more thing. When you write answers, you should be writing the units as well. For example, in this, what does the numbers represent? The number represents the number of people. Okay. So if you are not writing that people over here, then the question would be, what does 19? Is it the number of count of donkeys? Is it the number of count of dogs? What is it? Okay. So now let's move on to the second question. All right. So from here again, you can see there are two sets of people. First set of people are those that speak Tibetan only. So how many people are speaking Tibetan only? 50 people. Similarly, there are a set of people who can speak English. So how many? 46. All right. And total number of people that speak either Tibetan or English or both of them are 75 people. Simple. Now you need to find how many people can speak Tibetan only. All right. So the given is number of people speaking Tibetan 50. Number of people speaking English is 46. And number of people speaking Tibetan Union English is how much? You have 75 people. Clear? Okay. Now for the solution part. What needs to be found is how many people can speak Tibetan exclusively. Alright. So for that, from the previous relation that we discussed, you have to find number of Tibetan minus English, which is equal to number of Tibetan speaking people minus number of people speaking Tibetan intersection with English. All right. Now from the values given, you can see clearly there is no intersection. Okay. Value. So to find this value, number of Tibetan speaking intersection with English speaking, number of Tibetan speaking plus number of English speaking minus number of Tibetan Union English. This is the first relation, first question that we did. Okay. So this should be equal to number of Tibetan speaking intersection with English speaking equals to 50 plus 46 minus 75. 50 plus 46 minus 75. 50 plus 46, 96 minus 75. You have 1 and 21. Okay. So you can see clearly number of people speaking Tibetan intersection with English is 21 people. Now that being said, we were trying to find how many people speak exclusive Tibetan. So this should be equal to Tibetan minus English equals to number of people speaking Tibetan 50. Okay? Minus number of people speaking Tibetan intersection with English 21. So this should be 92 people. Clear? So, in this way, we are able to use the relation to solve questions. Simple. Okay. So next we are going to talk about the relation between three sets. Okay. So by three sets we have set A, B and C. So first the total number of elements in A union B union C equals to number of A plus number of B plus number of C minus a number of A intersection B minus number of B intersection C minus number of C intersection A plus total intersection of A, B and C. Okay. Similarly, in the second relation, we talk about the number of elements that are exclusively in two sets. Okay. That means either it is between A and B, or between B or C, or between C and A. Okay. So that relation is shown here. Likewise, in this relation, you find the number of elements present in single set only, exclusively to A or exclusively to B or exclusively to C. So those total number would be number of A plus number of B plus number of C minus 2 times number of A intersection B minus 2 times number of B intersection C and minus 2 times number of C intersection A plus 3 times number of A intersection B intersection C. Now, how did this relations came about? We'll be discussing next. Thank you. Okay, the first relation is number of A intersection B intersection C. So what is happening is in the Venn diagram, we need to take three sets. Set A, set B and set C. Okay. As the set grows, the number of intersection part is becoming more complex. In the sense, this region over here is the mixture of all the sets. Okay. So this region will be called number of A intersection B intersection C. Simple. This being the set A, set B and set C. Okay. So you must be knowing this region is clearly number of A intersection B. Likewise, this region, this whole part is number of B intersection C. And lastly, this part is number of C intersection A. Okay? Clear? Now, we need to find all the elements without being repeated. Okay, the count should not be repeated for the repeated elements. So, keeping that in mind, you have to find the number of elements in A union, B union, C. Okay, So this is equal to, if I add set A, total elements in set A, whole included. Okay. Set A is included. Okay. Plus set B is included. Okay. First problem. This is being added twice. Alright. Plus set C. After adding set C, what can be seen is this is getting added twice. This is also getting added twice. And this is getting added twice. Okay. On top of that, this part, the center part, is getting added how many? Thrice. Okay. Clear? Is it clear? So you have to make sure that these regions are added just once. So we subtracted it once. Alright. Similarly, this was getting added twice. So you have to make it once. You subtracted it. Similarly with this part, you subtracted it. So while subtracting, what happens is this was getting added thrice is now being removed completely when subtraction of these three took place. Okay. So you have to include this as well because union includes the whole region. Okay. So to include this, we'll add number of A intersection B intersection C. Simple. Now, for the second relation, if you need to find all the number of elements that are present in intersection part or that are being present in two sets, okay? When I talk about two sets, it is generally the intersection part, this whole part. Clear? Okay. Now, when we are talking about this part, so exactly in two sets. Now this would be equal to number of A intersection B plus number of B intersection C plus number of C intersection A. Okay. So to find the number of elements exactly in two sets, I'm adding A intersection B plus number of B intersection C plus number of C intersection A. But there is a slight problem in this. What is the problem is this part of the set A intersection B, B intersection C and C intersection A contains elements from three sets, not just two sets. So this part has to be removed. Okay. So to remove this part, what happens is this is being added thrice. Therefore, this portion has to be removed thrice. Minus 3 times A intersection B intersection C. Okay. This is the first relation and this is the second relation. Now for the third relation, we need to find the number of elements present in one set exclusively. Okay. So to find the elements that are present in just one set, we need to find the number of elements present in this region. Okay. This region and the given remaining region. This is the remaining region. So these three regions when add up will give me the number of elements present in just one set exclusively. So to find this, I'll add up first number of A elements plus number of B elements plus number of C elements. Okay. Clear? So when you add number of A plus number of B plus number of C, what you see is you are adding this whole thing, you are adding this whole part and this whole part as well. Okay. So while adding this whole part, what is happening? This part is getting added twice, twice, and twice. So we will remove this 2 times number of A intersection B, okay, minus 2 times B intersection C, minus 2 times C intersection A, okay. Now what is happening? You are removing it this 2 times. This is being removed 2 times. This is being removed 2 times. Okay. But what is happening to this part? This is getting removed more than 3 times. It is getting removed 6 times. Okay. It has to remove just 3 times, but it is getting removed 6 times. That means thrice more has been removed, which needs to be returned. So 3 times number of A intersection B intersection C. So from here our relation is complete. Okay. With that being said, we come to the end of the chapter 6. Okay. And before leaving, I'm going to give you a question. The question states that in a survey, it was found that 21 people liked Thentuk. Okay. 26 people liked Gyathuk and 29 people liked Bhaktuk. Alright. Now the total number of people is not given in the question. As you can see, the total number of people, I mean the union of all the people liking Bhaktuk, Thentuk and Gyathuk. Alright. So that has not been given. So that needs to be found before solving the question. Alright. Next we have, if 14 people liked Thentuk and Gyathuk, 12 people liked Bhaktuk and Thentuk, and 14 people liked Gyathuk and Bhaktuk. That means, and 8 people liked all of them. Now you need to find the number of people liking Bhaktuk only. That means the number of sets of people for B exclusively that needs to be found. Okay. So that being said, I'm going to end the chapter sets over here. Okay. I hope the chapter sets is clear. And then next chapter that I'll be going with is the chapter trigonometry. Okay. And since the people are requesting to go with chapter trigonometry, this would be my next chapter. Thank you.